Hello, everyone, and welcome. It is Wednesday, August 11th, and it's time for the Topher Spin Knowledge Bolide Hangout. We have so much good stuff planned today. We have a special guest, Daniel Shake, classifier to the stars in the building.
Excellent.
Yeah, and I think that he may comment on James Shelton's sample that is going to the lab, because he saw that earlier today in video and live. So he was looking at it with James. Maybe he might have a little bit of something to say about that, because last week, Daniel, maybe you can hit yourself off a mute if you want to give us any input, because we were dumbfounded what that weathered stone was last week we were looking at. It was a very weathered chondrite, and when we looked at it through the video compression, we couldn't really tell what it was, but there was a lot of metal in it, some really weird structures. What did you see in there?
So the thing is that I haven't yet received the sample from James, but if you could pin James so we could all take a look at the stone that he's holding right now, I think that would be good so we can all see what it is.
You gotta focus.
So upon first investigation, the first thing I noticed was the metal that's pretty much pervasive throughout the sample. You can see it almost like individual grains. And you can also see, based on the inside of the sample, it's a little hard to tell, but I did see what looks to be a couple potential chondrules, not that many, maybe a few. So if I had to look at this sample and, make a guess as to what it is, I would guess probably an L chondrite, maybe some higher petrologic type, maybe a 5 or 6. But beyond that, I can't really tell since it's a little hard to see, but that would be my best guess. Okay. Preliminary guess.
Yeah. This is a better view than we had at it last week. We can actually see the metal, whereas last week it kind of looked like someone I think Oz said Taza, and I agreed. So
you can also see some troilite as well running through the sample.
Yeah, that is awesome. Well, we can't wait to get that thing to the lab and actually get you some time to look at it there in Portland. How are you settling in, by the way?
Pretty good. It's been about a month here. I've pretty much I've got most of my stuff already moved over to campus. So all the thin sections, all the type specimens, everything is secure and safe on campus. So that's nice. Good. And I've already logged in 13 samples into Cascadia Meteorites collection. So there's still another 16 to go, and then everything's up to date. And then I'll get Chris's sample in there, and I'll work on getting James' sample in there and any other samples that I have thus far. But I do have something, maybe this is my first time showing something on camera, but I do have an interesting sample that I'd like to share with the group if that's possible.
Absolutely, buddy.
So unfortunately, I don't have it cut at the moment, but I have this meteorite right here. This is Oued Fayette, or Oued Fayette, however you want to call it. So this is an H5 fall from 2019 that I classified. It's my only fall, but basically this meteorite fell, I believe it was May 16th, and it took a couple weeks to recover. And it has a very
shield. Is that a shield? Is that a shield?
No.
Well, you could see roller overlap on the side, so it looks like it's not really too oriented, but it's got a very nice crust. You can see it's a very thin crust, so you can see the inside, but it's very fresh. And something also of interest that I noted on this sample, maybe not on this piece, but you could actually see metal veins pervasively running through the sample. So if anyone who was selling Oued Fayette, you would notice the metal veins running through, because it's a very shocked meteorite.
And that is a beautifully huge piece of it too.
Yeah, this one I was actually fortunate to obtain from Noordine Zelmat. He was selling this piece online, and I asked him, if he was willing to sell it to me, because I'd like to have a piece of it, since I didn't own any of this meteorite. And he told me he'd give it to me if I could help him out, get some stuff classified. So I helped him with about 3 or 4 classifications. So it's a very nice piece.
That is fantastic. How much is it? How many grams? Do you know?
About 160-ish. There's only about 2 point some kilos of it available. So it's a very nice piece.
Wow, that is phenomenal. I'm very happy for you, and it's nice to see the meteorite community sharing and coming together for our strengths.
Mhm.
I actually, Oued Saif is actually a meteorite that's close to my heart for one reason, for academic reasons. It's the first meteorite that I officially donated to ASU's collection. So they have Oued Saif. That's how I say it. They have it on in their collection. Not nearly as beautiful and big of a piece, but they have a little. They have two individuals on in their collection from myself. So congratulations, Daniel.
And just to mention real quick, I also did obtain some other pieces as well from some other collectors, and those ones I'll be happy to take photos of and share those on Facebook if anyone wants to see what the interior looks like. And a thin section. I have a thin section to share that as well.
Awesome. I definitely would be interested in seeing any exterior metal veins because none of mine had them. So that would be very interesting to see. Let me see here. We have, and we're going to check back in with Daniel later. So we're, we're not shutting you up for now. Chris Monk live in the building. Okay.
So I received a really cool rock yesterday, and it is
wow,
380 grams.
I know exactly what that is just by looking at it.
And you can see some cool little stuff just poking right out of it.
Wow. Before Chris, before you mention what it is, do we have any newer people that would like to venture guess? Someone who doesn't know for a fact what it is, but wants to take a little venture. All right. Nobody. Okay. How about someone who's pretty sure they know what it is?
Pretty sure you might need to get some extra saw blades there, Chris.
Yeah, that's a good hint. Does anyone now know what it is? There we have it. Thank you, Ron. Chris, take it on over.
So I believe it's a type 3. I don't know. I mean, we'll see when I cut it.
I'm thinking that's a Eurolite. Are we not on the same page?
If I would be surprised if this is a Eurolite, but I mean, if you look right there, and it's hard to see, but that big chondrule right there actually looks like a barred olivine.
Wow. I was my knee-jerk reaction was without a doubt. I was 100% sure I was looking at a Eurolite. The outside looks identical to Eurolite.
I could be very surprised, but if by the amount of chondrules that are poking out of this thing, and so the reason that I have all the weird stuff happening on my desk is because I actually hooked up my microscope to get a better look at it. If you want to switch to the other me, hold on, let me fix some of this start video. There we go. If you want to switch to the other me.
Whoops. Yep, go for it.
Let me.
Oh, yeah.
Yeah.
So if you can, let me find that one right there. So there's chondrules everywhere on this.
Oh, yeah.
Okay.
It's backwards. This is a really not that great microscope, but I mean, you can kind of see that the chondrules are just packed on top of chondrules when you get in real close, and all those little holes and stuff are almost like where chondrules fell out.
Wow. Look, go back. Yeah, look at that little puppy right there.
Yeah.
Well,
I think this one's going to be a good one.
Yeah, I don't mind being wrong because there's no egos here. I went out on the ledge and I just assumed it was a Eurolite, but it is not.
Let me there we go. So that's the one that I think is, and it shows up really weird on Zoom. When I'm looking at it not on Zoom, it you could see the like striations to it.
Yeah.
And this
Yeah, you
the
can kind of see
bottom
that.
the bottom part that looks like all dotted or like broken up. That's actually what it looks like. It looks like those same bars that go all the way through it are just broken into pieces. Like it was-
Polysomatic.
Yeah, there you go.
Yeah. Thank you, Pat Brown.
But I mean, this just everywhere you see, it's
Ooh.
just chondrules poking
Yeah.
out.
Okay. Yeah,
No,
that needs to be cut and then some thin sections made for Marissa.
Yeah, I don't even own a thin section, believe it or not.
Oh wow.
I
Well,
may need my own thin section.
next time you come over my house, you're leaving with some, okay?
All right.
There you go.
Even if you just borrow them to play around with them on your microscope, you gotta.
I was gonna say, Chris, if you want, with the 2 samples you sent me for classification, I think the thin section slices are big enough where I can ask the thin section makers to make 2 of them. So you can have 1 of them if you want.
Awesome. Yeah, that was if that's possible, I'm totally down.
Of course, yeah.
But anyway, that's what I wanted to show. It's just the single stone, but it's I was super excited as soon as I took it out of the box. And yeah, I can't wait to cut it. I'll probably start cutting it on Friday or Saturday.
Wow, that's awesome, man. Yeah.
Put a piece aside for me.
I will do that. And
Thank
this
you,
one
Chris.
might be I'm leaning towards I might classify this. And we had talked to Donald last week and he said, you know, he was saying that he was doing it too. So I might send a piece off to him just to see what he can do also. Keep my options open. And if not, a piece is coming to Daniel.
Nice. Well, since we're talking about material to different classifiers, and I owe Dr. Yang a favor, so maybe Daniel, I can tap you on the shoulder. We have an iron meteorite. We believe that the metallurgy says it's a meteorite. It's 80-20 a nickel iron. Who at ASU would be the best for irons? Because I know that like Chris Hurd is the Iron Man, but he's kind of backed up and he's in Canada.
Yeah. So he obviously was as of now, he's the primary person who deals with iron meteorites here in North America. John Wasson used to do it primarily, but then Chris Hurd is now using ICP-MS. And in terms of other people doing it, there's not too many labs that are doing it commercially for, for just getting, whether or not it's an iron or not. But I do know that there's this one company in Canada called ACT Labs, ACTLABS, and I used their services for one of the iron meteorites I worked on. And it's fairly reliable, I'd say. I mean, if you're trying to just figure out, whether or not this is like an ataxite or something, if the nickel is 20% in there, then that should be good enough for that. But I'd say if you're trying to really, figure out if it's like a specific subgroup of an iron meteorite, I definitely recommend waiting on Dr. Hurd as opposed to using ACT Labs. But if you just want to know if it's iron meteorite, I'd use ACT Labs. They're okay.
Awesome. Thank you so much. And we had Dr. Yang drop a chat, so thank us both for our time on that one. So awesome. Yeah. And so definitely, Sean, you can contact me later on Facebook and we can finish this conversation. But we're going to switch over to the wonderful sunny state of Texas right now with Ron Metchis in the house.
Texas. Bite your tongue.
We're in New Mexico? Florida.
California, dude.
California.
Cowabunga.
California. Wow. Sorry. Try to remember where everyone's from and I can't.
Hang up. Anyway, so what I have is a new acquisition. I got it actually about a week or two ago. I just got lazy. I haven't shown it yet. Let me switch over to another source. Okay, can you see that?
Oh yeah.
This is the rough side because it shows it better than the polished side. I'll turn it over in a minute. It's called the Jebel in Azine. It's from Algeria, Algeria. It's a kind of a rare iron medium octahedrite. And what caught my eye was this Widmanstätten pattern here. To me, it looked almost three-dimensional. Now, I'll flip it over. The other side has a big, fat, ugly fingerprint on it. Right in this area,
Oh,
right there. Oops, it's backwards. Right there.
Yeah.
Anyway, I'm gonna re-etch this when I get back from my vacation.
mhm.
But it's a beautiful little piece. It's 51.5 grams. I've had this about 2 weeks now, and I've been kind of working up the courage to re-etch it. So I'm gonna have to sand off a little bit of material because this was very. So price per gram, I don't even want to go into that.
Yeah.
So this is my latest little piece here.
Wow. I love over there on the far left side at 9 o'clock, dead center. You can actually see a crystal edge on.
Yes.
That's very
I
striking.
can get this up here just a little bit, maybe it'll show up. You see that
There it
big
is.
black spot there? That
Yeah.
was the fingerprint I'm trying to get off, and I only can do that is to re-etch it. You're talking, yeah, I see what you're talking about.
Mhm.
Yeah, there's a big fat crystal there,
Yeah.
and I think it goes all the way through. Let me flip it back over. A little bit of time, no, I guess it doesn't. A little bit of a time lag here, so I gotta, the way my camera works. But I think this Widmanstätten pattern is just one of the most beautiful ones I have in my collection.
Yeah.
It
Mhm.
just pops. When I get done with re-etching it, it'll be a lot nicer. I'll show this when I get back in a couple of weeks.
You better. Yeah. Because if this is the before, I can't wait to see the after.
yeah,
'Cause
yeah.
You're going to make that pop.
Oh yeah, absolutely. This is gonna be a beautiful piece when I get done with it.
Wow. From Algeria. Nice.
Yeah.
Oh.
That's what I have this week. You know, I'm kind of on a meteorite timeout right now. So
we get on those from time to time.
yeah, we're going on a very expensive vacation, so I have to kind of reel it in just a little bit.
Very nice. Well, we definitely hope you enjoy your vacation, and I hope that you drop in the chat exactly the name of that meteorite, so I don't have to hunt on the
I
map.
will. Right now.
And with nice. With that, I know for a fact that Cameron should be in Alabama. How are you,
Yeah, you're right. Good job.
bud? Okay.
You've written my address on enough envelopes, right?
Yeah.
All right. So y'all seen this before. This is shale from but it's shale. So this is pretty cool. I was very happy to get this, but then Alan Mazer offered these are shavings from a core sample.
Oh.
So drill bit shavings.
Nice.
Cool.
Whoa.
I guess one.
Oh, wow.
So I'm not opening it because it looks Topher, you
Yeah.
can say your trademark wafer thin if you
Yeah. It's only white for thin.
And
right.
it's got those layers, like those fingers there. Like you don't want to like open it up and find out that that's not all together.
Cameron,
Exactly.
are we actually looking at the thread cuts on that from a court?
Yeah, I
Yeah.
think so. I think so.
Wow. From
That's what I think
Hova.
it is. So
That's amazing, buddy. Congrats.
thank you.
Wow.
And then the other thing I have, if you want to play guess that species,
One.
Ooh.
got a little bit of crust there. I think I heard say Albright,
Albright.
which he is exactly right.
Ooh.
We're playing Meteorite of the Month Club.
That's it.
Exactly. This is 1.6 grams of the nameless new Algerian Albright. And for those of you that are curious about the long wave,
Yep.
it doesn't do anything.
Nothing.
Yeah, I
My-
tried that.
My piece does.
It
Your
does.
piece does.
Wow.
Then I
My
definitely want to
piece
see it.
does on both sides, but tiny specks.
That's cool.
I saw what looked like a tiny speck of maybe metal on mine that was reflecting the light, but I don't think it was fluorescing the light.
No,
Oh,
because
that's
it
because-
wasn't the same color as the light. It was like little yellow or orangey
Oh, wow.
spots. So
That's-
very distinctive.
Wow, the unnamed Albright. That's
Yep.
sexy, I think.
Yeah.
That's really cool. Now,
Yes.
that's really neat because most of the Albrights that we're familiar with that we've seen are like less than 5 gram samples of Norton County. So that's where we're seeing the Albright structure. That's what we're familiar with. But this is really cool because it's a slice. It's a a sliced sample versus you don't see a whole lot of sliced Norton at all.
If at all.
Wow. Yeah. Yeah. So this is like my first real opportunity to start seeing what Albright looks like when it's cut.
Yeah.
Wow. That's awesome, buddy. That's the Meteorite of the Month Club again, right?
Yep.
Breaking.
It's August. So
Sweet. Wow. Cool beans, man. Well, I also want to plug my buddy Oz and Chris because we went in on some of that Albright and we're going to have I think over 225 grams of it together. So
Wow.
definitely hit up Chris and oh my God, I'm blanking out right now, and Oz. And then once they're sold out, you can hit me up. Mike Kelly, what you got for us today, buddy? You got to turn your
How's
camera on.
everybody doing?
There we go.
So
Whoop. Sorry about that. I muted you, buddy.
no problem. So I just wanted to show off some of the stuff. I've been doing a bunch of cutting lately. So wanted to share some of the cut stuff.
Nice.
Obviously, you all just saw that.
That
That was the Albright. So
So
I got
you got your
lucky enough to
sample and
get-
cut it?
no, I cut everyone's samples.
Ah,
So I was stoked to get asked to cut up the modem for this month. So yeah, that was what I was cutting up for a bunch of time.
That's
So-
fantastic.
But you got me, Chris. I was thinking Eurolite because I just cut one of those too. And that L had that really jagged, triple junction look to it that kind of like a Eurolite has, which is what this is.
Mhm.
But obviously when you turn this one around and look inside of it, it's definitely got no chondrules in it.
Yeah.
But this one is, I'm interested to see, this is under classification. I'm interested to see what the write-up says about it. Cause it's got some pretty cool little reddish orange crystals in there. And I don't know if you can see kind of up towards my, my pointer
yeah.
finger. There's a couple of them there.
Mhm.
When they catch the light just right, it's pretty neat. I've been working on my polish a little bit too, trying to refine that.
Beautiful. Wow.
Also, you were talking about helping out Yang. Yang also sent some pretty cool stuff to cut up. So chopped up a bunch
wow.
of provisional CO for him.
Very nice.
Bunch
Carbonaceous.
yep. And guess what that one is? Probably one of the
Cicatric.
rarer of the achondrites.
Wow. I'm gonna go out on a one more. Oh my God, it's escaping me. Hold on. Lodronite.
Oh, those are up there. I had to check the numbers on those. This is 1 of 35. This is Angrate.
Ooh,
Ah.
even more so.
Yeah, so I gotta check the Lodronites. I don't remember what the total number of those are now.
Wow.
And then the
No wonder why I have no idea what it is. I can't afford an Angrate or a Lodronite.
And I'm glad Yang is on here because he also sent a bunch of mesosiderite to cut up.
Wow.
So-
cool.
I obviously did as he asked and halved all the individuals, and I'm glad he's here because I got those all halved up
Wow.
and they look good. And then I got to the last one, and on the last one,
Oh
I knew
no. Whoa.
I knew there was something good in there because about 3/4 of the way through, the saw basically stopped moving forward.
Oh,
And that last little bit took me quite a long time to go through.
Oh
And so
my
I knew
God.
there was gold in there.
Yes, look at that nodule.
Whoa.
Send me a
So,
picture of that, Mike, if you have the chance.
certainly, yeah.
Awesome.
So yeah, I just etched this about 40 minutes ago.
Wow.
And there's
Oh,
the two
mackerel.
halves, and that had a nice,
Wow.
That's
nice
gorgeous.
picture there for him. So that was all the fun that I've been having to cut.
Wow.
And you do a lot of cutting, you make a lot of dust. So one of the things I'm trying to do is these are meteorite dust impregnated centimeter cubes. I have to work on my technique to get some of the bubbles out of there. But I thought those were kind of a cool thing to do with the leftovers.
Yeah.
That's
Yeah, it
really cool.
is.
Man,
Very
So-
creative.
So that's what I've been up to.
Let's see that mesosiderite one more time. A slice with the nodule and a slice without, because it is just beautiful material.
Not only that, but that's an end cut too, right?
Oh
Yeah.
my word.
So the
Sweet.
It's
you know,
amazing.
the ones with the nodules, I finished up already. These are still off the saw, and I got to take
Yeah.
them onto the lap and get these ones all lapped up. You can still see it's got the little bit of cell marks on them, but it's got some pretty big pyroxene crystals in there. It's pretty neat looking mesosiderite.
Yes, it is.
I love mesositerites. They're very complex. When you get into them, you start looking at them. There's just levels of detail. And God, that nodule is just beautiful, man. Congrats to both of you on that discovery.
Well, I just do the cutting. I just enjoyed doing the cutting.
Yeah, but I know your heart skipped a beat when that saw started grinding down. You're like, what the hell is in there? That's awesome. Wow. Thank you so much, buddy. Super appreciative of you sharing that with us.
Yep.
Yeah. See, here in the meteorite community, we partner and get along with everyone. So Mike was doing the meteorite of the month cutting, and he's also doing stuff for Dr. Yang. So we're really a good partnership here. And one of the things that keeps us super strong is I always sorry, screens are popping up. I always surround myself with smart and intelligent people, and my goal is never to be the smartest person in the room, because then I stop learning. So at this point, I'm going to ask that Daniel Shake take the mic, and he is going to regale us. No, he has something that he wants to share with us about the METSOC and his presentation there. And he has also some other information, and we'll basically listen to him as long as he talks. So I'm handing it over to Daniel Shake, and we're super proud to have you as a Knowledge Bolide crew member, buddy.
Thanks so much, Topher, and thanks to everyone else. So a little backstory before I actually share what I'm about to share. So today was the Meteorological Society annual meeting virtual poster presentation. So basically anyone who is talking about from chondrites to chondrites to all kinds of research that they've been doing, they presented it if you were doing a poster. The actual meeting is next week in Chicago, and I'll try to take a lot of pictures of them there to share them with everyone. But the importance of having the virtual meeting was for anyone who couldn't make it, but it was also good because most of the people who had posters to present, they presented it in a unique format where everyone can type questions in and ask them, and they can answer them in real time, as opposed to if you go to those conferences and you see people presenting and there's like people passing through, and sometimes it's hard to ask questions because it gets loud, and it's much less of a hectic environment when you have these virtual sessions. So with that in mind, I presented my poster on an interesting meteorite. I'm sure some of you might have heard of it, called Erichidia 004.
Boom. Yeah.
It's a very unique Winnanite, to call it that. But can everyone see my full screen?
Yes.
Yeah.
Okay.
Yeah.
So I'll start off with an introduction, since Topher said I have some time to talk about this. So about a year ago, I think in March, I was contacted by Sean Mahoney, and he said that he obtained some interesting Winnanite-like material from a meteorite finder in Morocco. And when he was sending me these pictures, he sent me pretty much all kinds of photos. Let me use this. So there were pieces of this meteorite that was recovered that, that had lots of metal in it. There were some pieces that didn't have metal in it. And then there were some pieces that had areas with large amounts of metal, and you can see a visible Wittgenstein pattern, and then areas where you have a mix of both. So the interesting thing was most of these fragments recovered from this area were of very small pieces of only a few grams. So it's not like you had a gigantic piece. It's mostly like scattered fragments, but each of them has sort of their own different appearance to it. And when he sent these to me for classification, he wanted to know if there was any differences between pieces that had relatively high amounts of metal and pieces that have relatively low amounts of metal. So I thought it was interesting to make a thin section of both. And I decided to do it with these two fragments right here. So for all intensive purposes, we'll call this fragment part of the population of fragments that belong to the high metal population. And then we'll call this fragment as belonging to the low metal population. So he sent these two fragments in for classification. So the first thing, of course, to be done was to make a thin section of both. And after I made the thin sections, I decided to do the silicate mineral analysis, which means that I imaged both of these samples under the scanning electron microscope. So essentially, this is an image of the low metal population sample, and this is an image of the high metal sample. And at first glance, when I was doing the classification, I thought that the only difference between the two of them was the metal content. That was my thinking at the time. But I was in for a very nice surprise to find out that it wasn't just the metal content that was different. If you take a look closely at the two, you'll notice that the grain size of the minerals in here are different. So here, let me just explain what this is first, what we're seeing. This is exhibiting what's called a granoblastic texture, meaning that the minerals in here are roughly about the same size, and the minerals that this sample was made up of are primarily olivine and low calcium pyroxene. So we tend to call this an ultramafic rock. And these minerals are primarily meeting at boundaries that are about 120-degree angles. We call these triple junctions, and this forms as the sample is being heated on its parent body. So this sample formed likely at depth during burial on its parent body asteroid, and it was heated up. And so those mineral grains, or the minerals, while still solid, the grain boundaries were recrystallized and they formed these triple junctions. So this is a metamorphic texture you see in a lot of metamorphic rocks on Earth. Another thing you see in this lithology is that you have these veins running through.
Yeah.
And most of these veins are either iron oxide or troilites. There's not much iron nickel metal in here that's fresh. There's maybe a couple specks right here, but most of this is troilite, which is an iron sulfide. Now, when we look at, and the grain size of this is about 160 microns. So you can't really see it too well because this red bar is about 1 millimeter in size. So the grain size of these silicates, you can't really see it too well. But when we move to the high metal sample, we can see right away that there are some clear differences. The first thing, of course, is that the grain size is different. So we can see right away here the grain size of these silicates, which are these darker contrast phases here. For reference, the metal is this very high contrast phase, and the darker phases are silicates. And so this is about 400 microns, so they're more than double the size of the silicate grains in this portion. And we can also see that the texture is different. So normally in this sample, normally you would see the grain boundaries meeting at 120-degree angles. Here, the grains are almost irregular in size. They're basically angular, and they're kind of just meeting at these jagged boundaries. There's no distinct boundaries. It's kind of just irregular. And we can see that the metal is very visible here. In this case, it's very, it stands out. And in this particular piece, I believe the metal volumetric percent was somewhere around 30 to 40%. But some of these pieces that are part of this population can go anywhere from 80 to even pieces that are almost completely made of metal. So that was one of the prime distinctions I noted between the two. Now, what would you call this lithology? Well, I noted earlier that this had a granoblastic texture. This has more of an irregular texture between the minerals plagioclase and augite, which is high calcium pyroxene. So the modal abundance of minerals between the two samples is different too. In this sample, you have very little augite, very little plagioclase, lots of olivine, lots of low calcium pyroxene, or enstatite if you want to call it that. And in this sample, almost like the reverse, basically no olivine that I identified, lots of plagioclase. And so if I had to give an exact chemical description of this, I would call this more of a basaltic composition, which just means that the minerals are pretty much made up of course, plagioclase and some type of pyroxene. So this is ultramafic in composition, and this is basaltic in composition. So we have two distinct populations that have distinct grain sizes, they have different metal contents, and they have, of course, different chemical makeups. So right away, we're not just looking at one sample that has metal scattered here and metal scattered there. We're looking at one sample that has many different lithologies, at least two of them. So we call this a polymiced sample, but we still don't know exactly what kind of meteorite it is yet. So the next thing is to actually investigate and take the chemical compositions of the respected minerals in each lithology. So we can kind of get an understanding of what chemical group does it fall into. So that's where the geochemistry comes into play. And so what I did was I looked at olivine, which is along this axis right here in the middle, pyroxene, which is part of this quadrilateral right here, and plagioclase, which is on the bottom line. And let me explain each of these in detail. So I'll start off with olivine and plagioclase, since these are the simpler of them. So olivine primarily, when you're doing chemical groups of what kind of meteorites some of these samples fit in, the real elements you want to look in olivine are iron and magnesium, since olivine can have differing amounts of both. And some meteorite groups have distinct magnesium to iron ratios. And so this meteorite in particular is very magnesium dominated. There's almost very little divalent iron in the olivine. So this axis goes from FO, which stands from forsterite, which is just the magnesium-rich end member of olivine, all the way to phaolite, which is the iron-rich end member of olivine. And we can see that both the low metal lithology, which is this one, this was the only one that contained olivine, plots all the way pretty much where the end member forsterite is. So basically there's almost no iron in this olivine. Now for the plagioclase, plagioclase is present in both samples, although it's mostly present in the high metal lithology. The plagioclase goes from, in this case, I'm going to assume it's a little more complicated than this, but I'm going to make it very simple and say that there's two end member components to this kind of plagioclase. You have albite, which is sodium rich, and anorthite, which is calcium rich. So different meteorite groups can have, of course, sodium rich plagioclase, some can have calcium rich plagioclase, and then some can vary in the middle. Now this particular meteorite, both the low and high metal lithology tend to be more on the sodium rich side. So we tend to call this, they tend to be dominated by sodic plagioclase, which just means it has a lot of sodium in it. And we can see that the ratio of sodium to calcium in both of these samples, in both the low and high metal lithology, is almost the same. It's basically they overlap, so they're like identical, which is interesting to note because that tells us something interesting, which I'll explain in a little bit once I cover the pyroxene. So just keep that in mind, they're pretty much similar. Now for pyroxene, when you're doing pyroxene, there's essentially, you can view it as 3 or 4 end members. So for pyroxene, the elements that tend to be looked for when you're trying to distinguish meteorite groups are, of course, iron, magnesium, but now we have calcium as well. So generally, this would be a triangle, and you would have the magnesium-rich pyroxene, which is enstatite, the iron-rich pyroxene, which is ferrosilite, and then, of course, you'd have a calcium-rich end member of pyroxene. But in this case, we actually have a quadrilateral because due to the way the structure of the pyroxene minerals, of how the pyroxene minerals behave, calcium can only substitute for one of 2 sites, meaning that pyroxenes cannot contain 100% calcium and no iron and no magnesium. They can only go up to 50%. So we form a quadrilateral, and we have two calcium-rich end members. You have Heidenbergite, which is the iron and calcium-rich end member, and then you have diopside, which is the magnesium and calcium-rich end member. And in terms of what kind of pyroxenes you find in these samples, there's two types. You have high calcium pyroxene, which means it has high amounts of calcium, and you have low calcium pyroxene, which means it has low amounts of calcium. So we have the two distinct populations here. So when we look at the low calcium pyroxene, we can see it has very low amounts of iron in it. And the way to see this chart, if you're a little confused on how it works, so whenever you're going to the end member, we assume this is 100% magnesium. This would be 90%, 80%, 70, 60, 50, 40, 30, 20, and 10. For the calcium, it would be 0, 10, 20, 30, 40, 50. And then for the iron, it would be 10, 20, 30, 40, etc. So these are called ternary diagrams. And essentially, this is showing that the pyroxene has very little iron in it and very little calcium. So it's basically almost a complete magnesium-rich end member for the low calcium pyroxene. In between both lithologies, it's basically the same. Now, when we go to the high calcium pyroxene, we have about 40-some% calcium, or not 40, well, 40-some% calcium if you're doing a ratio of calcium over calcium, iron, and magnesium. And it tends to have a decent amount of magnesium in it too. So again, almost no iron in this type of pyroxene. And of course, between the two lithologies, they overlap. So they have the same chemical composition between their pyroxenes. Now, what does this all mean? Well, you'll notice why I have these red lines or red boxes plotted here. And that's because these red boxes are where the composition of pyroxenes, olivine, and plagioclase from the winonite meteorite group plots in. And as we can see, these points plot all within that group. So in terms of its silicate mineralogy, both of these lithologies are technically part of the winonite meteorite group in terms of their silicate mineralogy. But what's also interesting to note is that even though the textures are different, the metal content's different, and the grain size is different, and even the relative abundance of these minerals are different, why are their chemical compositions the same? And this will sort of be tied in at the end with the conclusion, but keep this in the back of your head, why they're the same, why aren't they different? You know, I mentioned they were polymits. Shouldn't they be different, but they're not? And that I'll explain in a bit. Now, another thing that was done to determine what type of meteorite group these two lithologies belong to is one way you can do this is by obtaining oxygen isotopes. Now, I don't do oxygen isotopes, but a colleague of mine, Dr. Karen Ziegler at the University of New Mexico does, and she managed to obtain oxygen isotopes from fragments of both high and low metal lithologies. And on this graph, what you have plotted here is basically, you can take this as the rough amount of, this is called the delta 18O, which is just, if you want to take this roughly, the amount of oxygen 18 in the sample. It's more of a ratio, but we can take it as just roughly how much is in there, against what is called big delta 17O, which in the meteorite scientific community, this is just showing relatively the deviation of where the meteorites would tend to scatter from a known value, which is a terrestrial standard. So in plain English, what this means is that meteorite groups plot in distinct areas when you're comparing delta 17O to delta 18O. And winonites specifically plot within a certain region on this graph. And this region is highlighted by these dashed values right here. It's within this area. So we can see both the lithologies plot within the region for where winonites plot in terms of how much oxygen 17 and 18 they contain. So this confirms with the silicate mineralogy. So this is saying winonite, this is saying winonite. So they're in good agreement. And just in case to determine something else about this sample, I wanted to determine what the metal chemical composition was, because the high metal lithology contained a lot of metal. So I figured, what if you extracted some of that metal and you ran it to determine what kind of elements were in there and what that could tell you. So a colleague of mine, which we actually just talked about, Dr. Chris Hurd, him and his graduate student, Patrick Hill, they did ICP-MS analysis of the sample of metal grains extracted from this lithology. So they actually removed metal grains and then they dissolved them and then they ran them to get chemical compositions. This is plotting on the bottom right here. This is just the raw data values of siderophile or iron-loving elements, meaning they fall within the metal. And this is just their concentration. So this is just saying that there's 7.4 weight percent of nickel, 0.3 weight percent of cobalt, and then you have all these other trace elements. For example, these are highly siderophile elements and some other elements. And why this is important is because I don't have the graph here, but iron meteorites are divided into, I think, 17 to 18 groups by chemical composition. And this is mainly determined by these elements right here. So that's why when you're trying to figure out what kind of iron meteorite you fall into chemically, it's important to get these elements because otherwise you can't do that. And so the metal coincidentally falls into what's called the 1AB iron meteorite field. And that's interesting because there's a lot of research that's been done looking at these 1AB iron meteorites and finding out that there's actually a potential correlation between winnanites and 1AB iron meteorites.
Whoa.
And the current idea is that they're likely derived from the same parent body asteroid. So
That's crazy.
It isn't too much of a surprise to find this, but what this likely shows is that this meteorite, or at least this lithology in particular, contains both parts from 1AB iron meteorites and from what you typically know as winnanites. So this lithology in itself is a mix of two lithologies already, which is very interesting to say. So now that we know all this, let's tie it all together into the conclusion. So the textural characteristics, the chemical characteristics, and the isotopic work that's been done of Eritchia 004, both the low metal and high metal lithologies, confirm that this meteorite is in fact a winnanite. But although it's listed on the METBOL as just winnanite, I think it should be listed as a polymixed winnanite because you have two distinct lithologies present in this sample. And I think that's something important that should be noted because in order to obtain something of this manner, that first requires that you have your parent body asteroid, which we can assume to be a chondrite. It experienced some partial melting and some slight differentiation, which all that means is that there was melting going on the inside of the asteroid due to radioactive heating. And as you were having that happening, some elements were moving towards the core, some elements were staying in the crust due to how they behave. But as that was happening, it never got to completion. Like how the Earth has a crust, mantle, and core, these bodies never got to that point because this planetesimal was disrupted by a large impact. And that broke the whole body apart, and the pieces fell back and reassembled and formed what's called a rubble pile, meaning that you have parts from the core mixed in with parts from the crust, and everything's kind of mixed up. And that was sort of the primary idea as to how the winnanite 1AB parent body formed, because you have 1AB iron meteorites that contain silicate inclusions that match the chemistry of winnanites, and you have winnanites that have metal in there that matches the composition of 1AB iron meteorites. So there is a relationship, and they are definitely most likely from the same parent body asteroid. But what Eritchia 004 found was that it's a little more complicated than just that. And something that I think might be something that might need to be explored later on is the relationship between these two lithologies. And now I'm going to tie it back to what I think the relationship likely is. So what I likely think occurred was that this lithology formed immediately after the first impact event. So you had impact of the body, metal from the liquid metal from the core was disrupted and mixed in with a basaltic partial melt from the crust. And that formed this high metal lithology. Then the question is, how do you get this lithology to be mixed with this lithology? And also, why does this lithology not contain, relatively high amounts of metal like this one? Why is it almost absent of metal? And I think that's because there might have been potentially a second impact event that further mixed other material in the crust with existing material that already incorporated metal from the previous impact event that had later cooled. So it's either that there were two impacts that occurred on the parent body, which led to essentially forming a breccia consisting of a previous breccia and some other melt residue, or that you had one impact event, but that there was some other events going on inside the planetesimal. It was still hot, and you had some metal and molten silicate material that had melted out, and when that left the crust, you formed this residue-like material, and that it was emplaced nearby to this already existing brecciated material. But it's still complicated because the grain size is different. So generally speaking, in geology, the first thing you learn is that when you have igneous rocks with larger grain sizes, that means they cooled more slowly, likely at deeper conditions. So this is making me lean more towards the idea that you definitely have a rubble pile. There's things from everywhere mixed in, but was it just one impact that caused it? Or could there have been several impacts occurring over time that lead to the formation of this? So that's kind of where I'm at right now. I only looked at two pieces. There's still so many other pieces of this meteorite to look at. There could be some with a brand new texture. There could be some with a mix of both. And I think this meteorite needs more study to assess that. But that's why I think it should be important to call this a polymixed winonite as opposed to just winonite, because it really takes away from the importance of what this message is trying to convey about the winonite 1AB parent body asteroid and what kind of relationship this can establish. And to end off on one last point, I said, why were the compositions the same? Well, generally speaking, sometimes when you have impact events occurring, this impact creates heat. And so sometimes when you have heat caused by impacts, you can get what's called thermal metamorphic annealing, which means that you have heating and metamorphism going on because of the impacts that were occurring that generated that sort of heat and pressure-like conditions. And so what I think happened was that the silicate compositions from this lithology and this lithology had equilibrated, which means that the minerals had exchanged iron, magnesium, calcium, sodium, etc. And therefore you formed one uniform composition between the two of them. So it was heated on its parent body after this whole thing had formed, and then it was ejected and fell towards Earth. So that's pretty much so far what I have for this.
Truly amazing. Let me see here. I want to put it out there. If there's any scientist that would like to study Irichidia 004 more, I know that studying stuff, you never have a goal in mind other than to understand it. But my goal would be to make some Irichidia high and low metal material available. My goal would be to get the Met Bull updated as Daniel was talking about, because I'm one of the main mass holders of it, and I, along with my partners, we paid for this testing. So that's why I was just giddy as a little schoolgirl watching this presentation, because this has been a long time coming for me. And I'm really glad, Daniel, that you talked to its relationship, the winonites, to the 1AB irons, because before you went into that, if you just look at the metal on this one, it looks very similar to a mesosiderite, to my untrained eye.
Yeah, absolutely. Whenever you have samples that contain large amounts of metal and silicates, it's sometimes very tough to determine what this is just by looking at it. So the best thing you can do, of course, is just get the composition of the silicates and then just see whether or not it falls within that certain group or if there are some differences. So when I saw this, I thought, this could be something different. So I was at first initially skeptical, because when it was reported that these two meteorites were found in the same location, I first thought that maybe they were just two different meteorites that fell in the same place. But if that's the case,
what are the odds? What are the odds of two winonites?
Lines up perfectly.
Yeah.
And the fact that you have some pieces, which I'm going to do further investigation on, that have both high metal and low metal in the same piece. So that's kind of what I'm looking for right now, because that would already eliminate that idea that someone might throw that these could be different. But
Mhm.
it's very hard, even within Winnenites. A lot of Winnenites, even though they can overlap in composition, there is still a range in their values. So getting, two samples to line up almost perfectly
Yeah.
in their compositions and in isotopes almost, even though there is a range, I think these two are from the same source, and I think they are definitely
Mhm.
indeed from the same meteorite.
Yeah, I'm glad that we went through all the extra time and energy and expense, especially during the COVID with everyone shut down, and really scientists' time and lab time was hard to come by. But we kept on this and kept on it, and us main mass holders, we wanted Winnonite is a rare meteorite, and it's an honor to be a main mass holder with my friends. But we really wanted a one of one. So I have no problem if it helps bring the science circle complete, that I have more material available. I'll look through and see if I have any that you were talking about that show the dual lithography in one slice. And I have no problem, Daniel, making that available to you.
Thank you. That'd be great. I was talking with Sean earlier, and he has some pieces sent to me, and I'm gonna try to get thin sections made of those to try to see what's going on there. If you see by these backscatter electron images, they're really not that good. I kind of made them very early on when instruments weren't as available and labs were still shut down. And there's still chemical elemental maps that I want to make of these samples. So what these can tell you is where the magnesium is, where the calcium is, and then you can convert this into determining where the minerals are. And you can actually see the outlines of the minerals and their makeup. And those are much better quality maps to have than just these, because it's a little hard to really tell what's what in here unless I specifically point it out. So that's another thing I'm trying to get. So I'm trying to really get many different fragments, many different thin sections, and get mosaics made of all these pieces, and then try to build the story from there. Assuming, of course, that it's all related, which I think it is, but it would be good to have transitional pieces to help piece together these two.
Well, like you said, there wasn't a whole lot of large pieces. The vast majority were like gram and subgram, like you can barely make a thin section out of. But I have a few slices I'll look through for the sake of science, for sure. And also, from the entire Knowledge Bolide crew, thank you so much for your presentation and sharing this with us. I was greedy because it's my Irichidia, but we're so thankful to have you on our crew. Thank you very much, Daniel.
No problem. Thanks for having me on, Topher, and thanks, everyone. If anyone has any questions on this, I'll be happy to take that if we have time.
I do have a question, Daniel.
Sure.
So first of all, I feel like my 2 slices in my personal collection just went up in value after listening to that. But my question is there a chance that the iron in the high iron samples are from the actual impactor?
That's a great question. So generally speaking, when we're discussing, whether or not the iron comes from the impactor or not, there's always the question, like, for example, when you look at lunar meteorites and you find iron in there, the first thing that comes to your head is, okay, some impactor, like a conduit, must have hit this sample and given that. But if you were to look at what's called the highly siderophile elements, which are, let's see if I remember this, gold, rhenium, and then platinum, osmium, iridium, palladium, ruthenium, and rhodium, there are specific patterns you see in chondrites versus what you'd see in iron meteorite groups. And this reflects many things. For example, when you're forming cores, you get what's called fractional crystallization of siderophiles, and you get all sorts of things. But basically, the highly siderophile element profile for chondrites, for the iron in chondrites, is much different than what you see in 1ABs and other iron meteorite groups. So you can distinguish those right off from there. And another thing, of course, is that when you look at 1AB iron meteorites, some of them, you see like silicate inclusions in there. So it's like almost all metal and a little bit of silicate. And then those silicates match the same chemistry via oxygen isotopes or via silicate chemistry as winnenites. So then you ask the question of, well, how did that happen? If there's an impactor, how can you get, almost a full iron meteorite with some silicates in there? So the better hypothesis is that you had a parent body that contained both of those, and you had mixing going on. And you had some areas that came out unscathed with just iron. You had some areas that came out with just crust. You had some areas with a mix of them. And then you had some areas that maybe formed later on. Like I was saying, potentially if you had a second impact, you can get even more mixing of components. And then, of course, this raises the idea that if you break the core while it's still hot, you can get further segregation of different parts of the core. And then you can have, you know, the 1AB iron meteorite group forms a complex, and there's all these different subgroups within that complex. So it's super complex, and the simplest way to, you know, to go about it is just to assume that you had a large body that was broken up and you had all this mixing going on.
Awesome. Thank you.
That is amazing. While we're talking about 1AB meteorites, I have one show and tell that I want to show. This is a brand new meteorite for me. Pazanka from Russia. Now, I got this today and I haven't taken it out of the wrapper. So we're all going to see it for the first time today. And it should be breathtaking. Let me get my mic over here. All right. There she is.
Oh, boy.
Look at that. Pazanka.
A lot of big crystals there.
That's nice.
That's really nice.
And inclusions.
I absolutely love these inclusions that Daniel was just talking about. Look at how round that one is.
Oh,
Yeah.
Almost too perfect.
Yeah.
It's a
It's like a
chondrule.
bullet just got shot into it.
Yeah, it's a chondrule of metal, of sulfides. Yeah, this is my absolute brand new one. Look at that. Like, I literally ran out to the mailbox before the hangout today. So this is 141 grams of Pazanka,
beautiful.
1AB main group meteorite. Look at that inclusion right there.
Yeah.
Like a little bar.
Yeah.
Yeah, you can seriously get lost in meteorites in the detail. And then, you know, last week we showed you how to get lost in the detail of thin sections, but we're not even looking at this under a microscope yet.
Yeah, oh, yeah.
Yeah, it's just beautiful, beautiful material. So I want to thank Sergey for making this available to me for sure.
Don't get any fingerprints on it.
Oh, I think it's actually, I don't know.
Sealed.
I'm gonna send it to someone, have it sealed. That's for sure. That way I can play with it and hand it around to people and not really be too stressed about it. Hey, let's go to Bruce in New York and see what you got going on, buddy.
Oh, nothing too dramatic, but since we were talking about Eritrea 004, figured I'd pull out my slices. Let's see if that. So almost definitely need to get a better camera than the one that's built into the laptop. But there's one side. So this is the one that just, yeah, you can see a lot of the veining there.
Yeah.
Mm-hmm.
Those
So
the troilite veinings, if my notes serve me right.
So that was the one that you would label as low metal. I got these from Topher. And the high metal I got was an end cut.
Oh, nice.
But really, this part really didn't show like a whole, you know, it's not like, yeah, it's like not giant blobs of metal that you can start seeing a little bit there.
Mm-hmm.
See right there?
Yeah.
There's the little end. Definitely sticks a little bit better to a magnet. But just so, you know, people actually, you know, see the meteorite as opposed to just the graphics, I don't think really showed it off as well.
Yeah.
And then I have from the Meteorite of the Month Club.
Yep.
So
All right. Yep.
The
Yeah,
Albright.
the Albright,
Yeah.
which doesn't want to focus in
Yeah.
any better. And since Mike is on, it's like, obviously this is like a little cut line. I was like wondering how you went about cutting it. It looks like, did you like cut out like little square pieces of it or something? So obviously, like, you know,
Yeah,
So
most,
went a little-
most of it was cut along score lines because the amount that was sent over to me was basically exactly on the amount that I was trying to go without having any cut loss. So how do you do something without cut loss?
Jeez.
So most of it was grid scored and snapped. And you ended up with like one of the pieces where on the backside it didn't snap perfectly along the lines because that does have pretty big grain structure to it.
Yeah.
So sometimes when you're trying to score it and snap it like that, it does what it wants versus what you're trying to tell it to do.
Right.
And
Yeah.
wasn't Marcin also commenting how it was hard to cut with a wire saw because the wire was going between the crystals?
Yeah, he had mentioned that he ended up getting a very wavy cut to it, and then was losing an incredible amount of material trying to then take those wavy slices and lap them back into flatness.
Mm-hmm.
So I cut it with the Isomet 1000, and the slice cuts I thought went pretty smooth and very straight. So I didn't lose any material at all as far as really having to cleaning them up. But then you got to take the full slices and break them down for the Meteorite of the Month Club into the part slices.
Yeah.
And that's where you got to try to not lose material if it's something like an Albright.
Yeah.
Mm-hmm.
Yeah. Well, like I said, I have over 200 grams on its way in for me and my buddies, and I'm hoping that I don't have to cut any of it. I hope people want individuals because that's, I think, what really shows the crystal formation, especially on the outside of the pieces. And some of them actually have fusion crust, which I'm looking forward to.
Oh, yeah.
Oh, 1 second. Bruce, was that all that you had to?
Yeah, that's all I have today.
Okay.
Yeah.
Awesome. Awesome. Well, we're checking in now with our good friend Damjan in Croatia. Can you guys verify we are recording, please?
Yes.
Awesome.
Yes.
So Damjan, as you guys know, does phenomenal photographic work. And he is taking us for a ride today through his Antarctic samples. But just look at this, these chondrules that he has, just amazing. Yeah. So let's go ahead and get into it.
Hi, let me start this week's show and tell with my tiny collection of meteorites from Antarctica, whose cold deserts have up to now yielded more than 45,000 meteorite finds, which is almost double that from all the other continents combined. Unfortunately, due to international treaties, almost none of this material is available for private collectors, so for us, Antarctic meteorites might as well be extremely rare, as they are almost impossible to get. That's why I'm thrilled to have not one, but two such samples. Both I got from Alan Mazur, and both are actually historically significant. Teal Mountains from 1961 was the first Antarctic pulsite find, and only the third meteorite found on that continent, out of 45,000. It's also one of the finds closest to the South Pole. My tiny micro of this exceedingly rare meteorite I actually got as a gift from Alan.
That's cool.
My second sample, Alan Hill 7601, is actually possibly only the third meteorite found and the first meteorite that was classified under the US ANSMET project, from the first joint US-Japan expedition from the season 76-77. It's just an ordinary L6, but like L'Aigle, very significant in the history of meteoritics.
Mm-hmm.
And now the wonderful Teal Mountains pulsite. It's a gorgeous micro with both metal and olivine parts.
Beautiful.
Looks like fire.
I know.
If that's possible, the other side is even more beautiful.
Look at the fracture marks in the crystal, or the growth
Here
plates.
it is with a more diffuse lighting.
Holy wowzer.
Look at that.
Now from hot deserts, let me show you a few more macro shots from my probable L3 slice. I still can't believe how perfectly this unusual chondrule symbolically illustrates a fiery meteor. The colors are perfect. You can even observe the oriented shape, flow lines, roll over lip, and in-flight fracturing and breakup. The similarity is truly uncanny.
I love you, Damian. That is beautiful. Your poetic words are amazing.
Here you can see an obvious lunar inclusion. This is also, no wait, that's no lunar inclusion. Now, how did a hard-boiled egg end up in this beautiful glossy chondrule?
Andy's a comedian.
Yeah, I love it.
Okay, enough bad jokes. I'll shut up now and let you enjoy the rest of the macro photos.
He's gonna be on stage all week, guys. This is great. Look at this. Wow. He's calling that one a possible L3. I think he's erring on the very much side of caution on that one.
Really?
Well, it reminds me of Chris Monk's one in for classification that could be a possible LL3.
Look at that. That's just beautiful coloring too. A chondrule within a chondrule right there.
I have a close-up of a chondrule from Chris Monk's slice that he sent me on that LL3. But I didn't take a video of it. I took a still.
That's it for this week, and I
for some
hope
reason
you...
it's on my cell phone.
Well, this looks like the surface of the sun almost.
Oh, yeah.
That's it for this week, and I hope you've enjoyed my photographs.
We definitely did. You do great work, buddy. Thank you so much. Yeah.
Yeah, it's really incredible.
Yeah. He's a knowledge bolide crew member, long distance, man. We love you and love your stuff every single week, week after week. I have I see art. I have a little something I want to show off. That was a personal gift from my buddy Oz. So let me go ahead and turn this off. All right. So now, Oz knows that I love collecting gifts and witness falls. So here I have Marita. Marrera. Well, it's an L6 that was witnessed in December of 2012 in Mauritania. And what I have here is a nice crusted individual right there.
Oh, yeah.
Look at the
That
frothiness right there. So this is an L6. But this is going in my private collection under the gifts. Look at that. You can really see the detail in that fusion crust there.
That's a key.
Yeah. So Damian has showed that you don't need to buy 150 grams of anything to appreciate the beauty of it. And here's I think this is like 3 grams. Look at that little tiny bit of a rollover down there. This is like a little 3-gram piece. He would make this look like the Empire State Building.
It'd be like hobo or something.
Yeah, thank you very, very much, Oz. That was super generous of you. And here's the card, the Oz Backman collection. Super nice card with his information right there if you want to do a screen grab.
Cool.
Nice palisite on the back as well.
Where'd you get the card with the hologram, Oz?
Oh, I just bought the stickers on Amazon and I made the cards myself on
Gotcha.
Vistaprint.
Well, cool. Thanks.
Now, Oz, you want to tell us about this one here?
Well, this is I had a bunch of chondrites for ever since the beginning of last year. Some of them I bought from Matt, some of them I bought from you, some of them I bought from Sean Cachet. And this was one that I was really, really just in love with. Looking like an H5. I sent it to Dustin Dickens and he did an XRF on it. Nickel content is less than 1%. I think it was 0.61 or something. Iron is about 20. And it's looking like an H5 probable. Shock of 2. Weathering is pretty low, but it's gorgeous looking stuff.
Yeah, I love these white chondrules right here. There's 2 of them, and then there's a dark one right there. Yeah, it's beautiful stuff. So I appreciate that. This is super cool. I might have Chris touch this up on his lap for me and make it absolutely shine. So that one right there, we have listed as a probable H5W2S3, which is amazing information to have. We have the XRF data down there with the nickel and iron. So fantastic work, Oz. Really appreciate it, buddy.
Thanks. You're very welcome.
Yeah, it's always nice when you have a very busy day, a very long, arduous day, battling trolls. And the next thing you do is you open up your mailbox and there's a gift from your good man Oz. So thank you, dude. That actually honestly made my day. I'm not joking about that. Thank you. For our last and final check-in, show and tell, Mr. Art Wagner with his custom t-shirt.
I don't know if you're going to be able to see a picture of this chondrule on my cell phone, but
Oh yeah.
Oh wow.
That's the chondrule I found in Chris Monk's possible LL3 that's in for classification. And I was wondering if that's referred to as a bleached chondrule. I'm going into an area that I don't really understand, so probably that's for another time.
No, that's fine. We're all here to take our guess at learning stuff. I mean, I was guessing Urolite earlier, and it was a chondrite. It's hard to tell on that one. I think it looks like a bleached chondrite, but I would let anyone else ring in if Daniel is. Well, I don't know if Daniel's still with us or not, but it appeared to be somewhat of a bleached chondrule with the lines coming back out. But I tell you, you ain't got nothing on that on Damian's meteorite with rollover lip and orientation and everything.
Right.
That was crazy.
Well, he does the videos. I just did a still. I'm going to try to do a video and see if that has a better result than just taking a still photo.
Nice. Yeah, well, keep us informed on that. Definitely. I lied because you didn't have a real meteorite to show. It was a picture of a meteorite. I have to make sure that we have one last real meteorite. This is from Chile. This is Los Vientos 262.
Wow.
Oh.
Hold on, I got to move my mic. Okay, so this is an L6. Whoa. Okay. It's an L6.
Yeah.
And it's nice. It has brecciation. So a lot of the slices are nice and red on the inside and show brecciation. And I'm really thinking this is going to be a nice one once it's cut up. May not look.
Hmm.
Yeah. Now, I do want to point out, because we always say air holes and bubbles and stuff are meteor wrongs. What we're looking at here is an eroded surface, actually. So there we go. My phone finally started working. So what you're actually seeing is just the eroded surface. There you can see more fresh fusion crust, but there it's more eroded away. So those aren't air holes. Those are softer materials being eroded away. That's what that is. But when this is all cut up, Chris, it's going to be gorgeous. I'm going to let you plan the attack on this one yourself. I'm not going to even direct you on what angle to do it at. I think a man who's invested in isomet can be.
Did you have a shock vane in that, Topher?
I'm not exactly sure. I don't think so. It has like that's a crust line, I think, is what you're looking at right there.
All right.
Yeah.
All right.
Yeah,
It looks
it's
a little bit. It looks a little bit like it's got some like weathering fractures too.
Yeah, yeah. It should be interesting. You'll be the first human ever to look inside of it, so you'll tell us how beautiful it is. Hold on one second.
I noticed that when you stopped it.
Man, we had a great, amazing hangout today. Thanks so much for everyone, especially a big thank you to Daniel Shake, our resident
Daniel.
scientist. Yeah, it's really powerful to have intelligence and expertise of that niche available to us. So we're indebted. Thank you very much. And everyone who showed off something, thank you very much. We're going to continue the hangout without being recorded because we're going to get into some good stuff now. So check us out live next time. Have fun, guys.
Have a good week, everybody.
Yep.